everyone, good day, and we will be talking about thermal expansion. So, what is thermal expansion? Thermal expansion occurs when a material increases in size or volume when heated. It is a fundamental property of solid, liquids, and gases, resulting in increased movements of particles at a higher temperature. So, the importance in physics and engineering. Understanding thermal expansion is crucial for various engineering applications. It informs the design of structures, bridges, and railways to avoid catastrophic failures caused by thermal stress. Like, imagine a concrete, concrete road. There are ridges. So that's for thermal expansion. When the concrete is heated, it expands, and our that's the ridges are for. That's what the ridges are for. So here's some examples. The expansion of metal in hot weather, the fitting of concrete slabs, the functioning of thermostats. So imagine a thermometer. The mercury inside it expands, and that's what tells you the temperature. That's thermal expansion. So let's back off from that. Types of thermal expansion. A linear thermal expansion refers to the change in length of an object. It is characterized by the linear expansion coefficient, typically expressed in units of length per degree. For materials, that is change in small but significant in engineering applications. Just like what I said, that thermometer. It is an example of linear expansion. The rising of the mercury inside it, that's what tells you the temperature. So another type of thermal expansion is area expansion. Area expansion describes how the surface area of the metal increases with temperature. This phenomenon is essential for applications like design of buildings where expansion joints accommodate surface areas changes due to temperature variations, presenting structural damage. Like imagine a house. When it's heated too much, the concrete cracks. That's thermal expansion. So, volume of thermal expansion. Volume expansion. Volume, volume expansion occurs when a material changes their volume as temperature rises. Expands upon heating, the volume expansion coefficient quantifies this change, affecting various systems such as pipelines and storage tanks. So, when water is heated, the water expands, and it when water is heated or cooled, the pipelines will be frosted and it will expand. So that's what causes the cracks inside of it. Understanding the factors influencing thermal expansion. Material composition. Different materials exhibit varying coefficients of thermal expansion based on their atomic structure and bonding. Metals typically expand more than ceramics, while polymer may demonstrate larger expansion rates at certain temperatures, significantly impacting design and usage in engineering applications. Temperature change effect. As temperature increases, most materials expand, a basic principle of thermal expansion. However, the rate of expansion can vary wildly. For example, water expands differently at 0 degrees Celsius and 4 degrees Celsius, illustrating that temperature change impacts expansion behavior significantly across different phases of matter. Environmental conditions. Environmental factors such as humidity and pressure of the surroundings can influence thermal expansion. For instance, material may expand or contract more in a moist environment due to water absorption, which can lead to structural issues in construction and engineering. So, applications and implications of thermal expansion. Engineering applications of thermal expansion. Thermal expansion is critically influenced. No. Thermal expansion is a critical in engineering, influencing the design of components subjected to temperature changes. Engineers must account for expansion in materials such as metals and plastics to prevent structural failures in machinery and vehicles. Just like the engine of a motorcycle or a vehicle, that is engineered to account the expansion of the metals in the engine, so it will not fail. Next, construction considerations. Construction considerations. In construction, thermal expansion must be integrated into building design to avoid damage. Expansion joints are example of solutions used in bridges and buildings to accommodate temperature fluctuations without compromising structural integrity. Imagine a bridge. The bridges has expansions, expansion gaps. Those are engineering designs to mitigate the thermal expansion. Real-world consequences. Neglecting thermal expansion can result in serious consequences, such as buckling, cracking, or even catastrophic failures. Historical events like the collapse of structures due to inadequate thermal management underscore the importance of understanding this phenomenon. So, that's all. That's understanding thermal expansion, the science behind materials expanding and contracting. Thank you.